talk a little bit about. Good morning, everybody, and welcome to Physics B. I know some of you are sitting in my class Physics C, for C that is. So this is Physics for B. And I hope that you guys were able to do the things that, okay, some of you are sending me messages right now, and I really cannot see them. And if 3 messages are actually on the other one. Let me talk to you a little bit about how this class works, okay, so that we are all on the same page. Okay. So this course is about Physics V, which is electricity and magnetism. It starts from the book on chapter 21 and ends on chapter 32. So there are a total of 12 chapters in this class. And this is a long class in the sense that it has a lot of stuff in it to be covered. It's a calc based, so that from the get-go we have no confusion about it, so that there will be calculus in this class. There will be specifically something that has to do with the multivariable at some point, basically integrations and derivations and stuff like that. So I'm hoping that you guys will brush up on your math. Most of the times you will see, though, all of these problems, which are inherently 3-dimensional problems, will be reduced to 1-dimensional problem, in which case the integration will be reduced to just of a single variable, or the derivation will be that of a single variable. So most of the times, I would say probably more than 95% of the times, that's the situation. Except at the end, toward the end, where we really have to get some partials and have to start splitting things and making things on one side and the other. And that is when we get into basically how to solve Maxwell's equations in vacuum. And at the end, we will be basically forced to use the full-fledged Maxwell's equations to work with them. So that's basically from the get-go, so that we guys have an understanding of that. I know I sent a message yesterday about the mastering physics. And it's very important that you sign up to that one. I know some of you probably who are sitting in 4C, they have it probably different link, but it's still the same thing. So I'm hoping that you guys will sign up for that and do your homework, because if you don't do that, you'll be missing on a big chunk of your grade. So we don't want that, okay? So let me go back into here. Do you guys have any question up front in here for me? Okay, looking at this, do you guys have any question for me? No? Were you able, at least I need one or few of you confirm the following, that when you go onto Canvas, you will see the first assignment that is there for Physics 4A, because I'm assuming all of you took Physics 4A.
I can see it.
Okay, very good. Were you able to open it and see the assignment, exactly what it is? Yes, no?
Yes, I can open it.
Okay, very good. Okay, so here is the stuff so that we are on the same page in here. Let me go back into the modules. When you come into this class, I want you to spend all the time on the models page, okay? That is where most of the action will be. That is where everything, not most, 99% of the things will be happening. So you would want to come into the models and see what's going on. One of the things that we start with is usually the community rules, because I'm hoping that you guys will be able to communicate in a fashion that is basically helping in this class. Now, it is important that you engage in this class. It is very important. As a matter of fact, you will miss grades if you don't. So, and it starts with this discussion points in there. Okay, this is one of them. So if you see that, let me switch first of all the view to that of a student. and see if I can share that screen with you guys. Share the screen. Okay. So what you see in here, for some reason, I lost my chat and all of the rest of the stuff in there. Can I look at it too? Yeah, okay, good. Okay, so what you see again is this idea in here. Some of the items are required, and you will see them, whether or not you completed them or not, okay? So the community rules, I'm hoping that you guys will go through it and understand basically on how to communicate in this class and so on and so forth. The other thing that is in there is this assignment, okay? This has two very important dates that you please observe them. The first one is this Saturday. Is this Saturday the 20th, or did they get the wrong date? Yes, it's the 20th is the initial response time. This is the initial post, where you're going to answer basically the following stuff, okay? Include a little about yourself, basically. What is your preferred name? I know that some of us have different ways of calling ourselves and so on and so forth. So I'd like to know that, okay? So you need to be specific in here and how to be called. And also about the gender, okay? Sometimes I get things confused, so please make sure to get this thing correct. And also include a picture, hopefully large enough, of yourself so that I can see basically, or your classmates actually can refer to you and know exactly who you are, okay? So that's one of the things. And also, again, you're going to look at item 1 or item 2. One of them is basically, it says that the 3 laws of Newton in here are all there is to know. So why in the world we need other things? So again, so you're going to answer that question. And the second one has to do with Kepler laws, okay? So pick up an item in there, try to understand it, see what it says. Why do we have to go past beyond the chapter 4 or 5 in the book, basically past these things? So that's the question that I want you to answer it. This has no right or wrong answers, basically. I need you to really think about it hard and give me a rationale and argument for it, okay? Obviously, we needed to go past beyond it, okay? So in here, I have a different explanation of the Kepler laws. I know that you guys have covered that stuff in there. And I want you to find the flaw in my argument in here. Why in the world this is not good? So I want you to also find that. And that, one of the 2 items, you're going to pick up and then start discussing them and post your answers in there. That's by this Saturday. Then by next Tuesday, you will have to reply to 2 of your peers, okay? Pick 2, hopefully, that nobody replied to. And then again, basically, if you agree with their point or don't agree, and make an argument for it. The word agree or don't agree by itself does not stand for much, okay? So I really need to see a discussion here going on. This is just to get us going. In order to get full credit for this one, you're going to come to show rubric, and you're going to see exactly how you're going to be graded for this assignment, okay? This is a common theme for all of my classes, actually, not just for you guys, is that there are rubrics for everything that I do with you guys, and you really have to observe those rubrics. So that's really a guideline for you guys to be able to actually see how you're going to be graded. I mean, if somebody else wants to grade your work, they can. They still have access to it. They can see exactly how you're graded, and they grade them. As a matter of fact, you can grade yourself. If you met all the requirements, you shouldn't have difficulty basically with that. So that's really one of the things. And it's true for all of the assignment, not just for this one. So there should be clear guidance into how you're going to be graded. So pay attention to those rubrics while you're answering stuff so that you know exactly what is expected from you in this class, okay? So why is this thing not sticking in here? Okay. So that's one thing. The other thing also, there will be a summary of always of the main concepts that are covered in that chapter. So you really need to pick up on those. To pick up on those key concepts, including what's going on. And then there is another thing that toward the end is assigned, okay? Which is the discussion for each time we have a live session. So again, let me go back into the student view in there. And let me pick up that one and share with you what I mean by discussions, okay? This is going to be true for almost every week. You're going to be seeing this. So it's very important that you guys pay attention to this discussion things toward the end, okay? Okay, why? Oh man, let me turn off the student view right now because it's waiting for me to upload these things. And I will tell you exactly why that. So this is how, when you come in, there will be a video in here. Actually, this is the very same video, a link to it on my YouTube channel so that you guys can see it, which is a very good idea that you guys subscribe to the YouTube channel so that you see. Sometimes it takes time for me to basically upload the video and basically edit it first and then upload it. And sometimes Google takes forever to index it and tell me that it's ready so that I can come in here and put the link for you guys. So it's a good idea to have it when it's ready. Google will notify you that, hey, there is a new update there. Of course, I have so many classes, probably it's not of interest to you, but at least the one that interests you, if you really need to get to it, you get to it right away. So in this case, there will be the discussion that we have in there, the live session that we have today, it will be here. And for every session from now on is going to be the discussion items in there. Now, here is the problem. I will have questions for you during the entire live session. And these questions can be 1, can be 2, can be 3, can be 4, up to 5 items of discussion that can be there. Items, for example, for example, verify my numbers, check if the results that we did when we tried to solve that problem is correct, or finish the calculation, okay? Or check something in here. Is this concept, is this definition correct? Is this law? Can you put it in your own words, okay? So those are the things that I'm going to be expecting from you. Some of them will insert them right then and there. Like, for example, a problem we solve, we try to find a solution for it. And once we find it in there. And because of its relevance and importance, I will ask you to redo it again in the discussion, or at least state the result and explain it. So the answer is actually in the live session. If you attend the class live, you should not have difficulty with that. Here is the plan though, because you don't know if there will be 1 item of discussion or 5 of them, okay? So when one comes up, take a note of it and take a note of the answer. Do not right away go and post the answer on the discussion session, okay? Wait until the live session is over, and then now you have tallied. Let's say, for example, there were 3 of them. Then you know that there was item 1 and 2 and 3. So you're going to go in the discussion and post them in there and you're done, okay? Now, if you're not live, let's say, for example, you couldn't make it for one reason or the other, I already have 3 messages already from some of you guys, then you are required to come in here and watch the recording. And because you don't know when they will happen, they could be in the beginning, they could be in the middle, they could be toward the end. They could be at any point in the time, and there will be no recap at the end of this items. So you're not going to come toward the end and say, oh, these are the items, therefore this is a discussion. So there is no way to shortcut this thing except to actually watch the entire lab session, record it, and then basically do the same thing as a person who's attending live, except the person who's attending live will benefit from asking questions and clarifications and things like that. And then also take a note of these things, and at the end you answer them. Okay, somebody else might say, okay, how about if I do the following? Skip all of that, come just to discussion, see what points have been raised, the people who have watched or attended what they have said, and I'm going to just copy what they have done, and that's it. And I'm saving myself about an hour and 25 minutes of class. That is not going to work because you're not going to be able to see what has been posted unless you actually post first. Okay, so if you post, then you see what everybody's been talking about. Now, if you decide after you post, you know what, I just wanted to see what they were talking about, that's all, so I put some nonsense stuff, then I know what the point of the discussion is. Canvas keeps track of what was posted and what was edited. If your item has been edited because you changed it for one reason or the other, it will nullify it. I will nullify it. It's not going to be graded. You're going to be receiving 0 participation grade for that specific item. So in other words, what I'm trying to say is you have to be honest about it. Attend the class, take notes, especially of the discussion items, and post them at the end when you're done, when we're completely done. If you cannot make it for one reason or the other, you have to do the same thing. You cannot shortcut this one way or the other. You have to actually honestly pick up the items in here and there and post them. Sometimes by mistake, you hit the submit button and that was too early. I'm going to be lenient the first time around, but after that, please, you have to make sure you're going to pick up the items of the discussion. Is this clear to everybody who's here at least? Do you guys understand the process?
Yep, sounds good.
Yes.
Okay, this is the item of the discussion today. How to answer this discussion prompts, how to get your grade of participation. Okay. Again, what you're supposed to do is take notes of the item or items that have been raised on that day. Okay. They can range from anything. Okay, like this one today. And when the class is over, you go in there and you post your replies to it. Okay. You cannot edit your reply once it's posted. If you cannot make it live, you have to watch the recording first. Do the same thing, taking notes. Do not post a reply until you're done watching it. Then post your reply or reply to that item with one, to that discussion item with one or many items in there, up to 5 items per session. Okay, that ensures that you are actually doing the work you're supposed to be doing and get you a grade for participation. If you want to skip this participation grade, your grade is going to be out of 90 from 100. And I don't recommend that. That's not actually a good idea. Okay. So this is basically item number 1 for the discussion today. And I'm hoping that you guys will pick up on it. Okay. So that's how the process works. Any questions about this? No? Okay. The lab sessions, usually there will be not questions at all in it, but if there is, it's going to be incorporated into the lecture lesson questions, okay, the discussion there. But lab, you're supposed to be doing it anyway, okay? Good? Okay. I want you to also pay attention to the syllabus. I know I sent it to you guys, a printed version of it, but I also sent it in terms of I posted it also on Canvas. So hopefully you guys pick on it. What is important about that is actually, I mean, everything is important in it, how you're graded and all of that is very important. Please pay attention a lot to the rubrics, very important, okay? For you guys, the midterm, there are 2 dates. For right now, because we are under 16, the entire enrollment in this class, we're going to have our midterm on Tuesday, April the 20th. Make sure that this is the, oh man, did I lose it? Okay, hold on 1 second. Okay, guys, let me make sure I have the right stuff in here. I don't want you to give you the wrong date on it, because on that week I will be busy. I have about 5 classes on campus to be tested. Where is it? Again, class roster, spring semester, and it's this class. Yeah, I know I sent a couple of codes, so maybe we will hit that mark of 16. If we exceed it, then we have to be divided into 2 groups, because the campus does not allow more than 16 students per class attending an exam. That's why they gave us 2 dates in there. One is actually on the 20th, and the other one is on the 22nd of April. Okay, so those are potentially 2 dates that you guys can do the exam. Right now, if the number stays less than 16, that's where we're 16 or less, that's where we're going to be on the 20th. And the final is going to be on June 8th. Unless the number increases, then we're going to be on, we will also have a choice between the final June 8th and June 10th. Something very important I mentioned in the syllabus, and please read it carefully and try to understand what I'm talking about in here. If for one reason, regardless of the reason, okay, of course, it has to be valid for you to be excused from it, at least to be allowed for the process to be it. You cannot make the midterm live, basically on campus. Then we are going to probably work out something in a sense of making it up, okay? Depending on the reason and depending on the accommodations and things like that. Of course, exam 2 is going to be on online, so we don't worry about exam 2. And if for similar reasons or whatever other reasons, you cannot make the final either, then regardless of how much grade you have in the class, is going to be an incomplete grade. You have to take the exams on campus, okay? At least one of them has to be on campus, okay? That is the policy that we're going to go by. Now, if you cannot make an exam, then we have to work out the details, basically, of having the time for me and you, basically, to be on together. Then we probably can do it online, provided you have a camera, and you open the camera so that we can basically see that you're making sure that you're not given a different setting than your classmates, because your classmates were under a setting and you're doing differently, so it's not going to be fair toward them. So that's really the motivation for that, okay? Is this clear? Because it's kind of maybe confusing. Yes?
Yes.
Okay, please make sure you do everything possible to avoid the other conditions where you're either going to have to take the exam at home with the condition of the cameras and all of that, or having completely missed both of them, and in that case you're going to get an incomplete, in which case you're going to finish it later on time, which is probably not a good idea, because you probably will have other classes and other things that you would want to take care of, okay? So including, for example, if you happen to be feeling not good or anything like that, there is an app. I don't know if you guys had the opportunity to do it or not, or other instructors told you about it or not. Is the Guardian app? Do you guys see that? I posted it on the. This is how it looks like on my phone. We are required by campus policy to have this one up actually before the day we go in, to basically state that we are good and we don't have any symptoms and we don't have anything else. So this is a something that is required in here. Right now it says location, if you see it, location restricted, because I did not enable the location. So if I'm going tomorrow to campus, I have to enable the location, and I have to answer the health questions that I don't have any fevers or anything like that, to make sure that again, this is for your safety. You don't want to be walking around with faculty or other classmates who probably have been exposed or don't feel well or anything like that. You don't want, I mean, the last thing you would want is to be spreading something that is undesirable, okay? So that's basically one of the things. The other rules, please observe them in terms of coming only for the exam and leaving. Do not hang around during those times and talk and chat and get to exchange stuff. And then the other thing also is the parking. They want us to park and leave a space for a car between the two cars. You cannot go next to another car and park next to it, so that you're driving, okay? And if you're waiting for a ride, you have to wait at a distance of 6 feet or more from somebody else who's waiting also in the same area, okay? So this is in a nutshell, that is an exception. Everything else is the same. Everything else is the same thing. The grades are in there, I mean, how they are going to be distributed, and the chapters in there. Okay, so this is in general for the class. So I'm hoping that you guys will have a chance to go through this once. And if you have any questions, please ask me, okay? No? So we're going to start this class. Okay, so again, as I mentioned before, this course covers electricity and magnetism. And basically chapters 21 through 36 from the book. And if you happen to have the 14th edition and you don't have access to the 15th edition, the e-text should be fine. And there are actually very little difference between them, if any at all, okay? There is only sometimes the problems. They're numbered differently. I think there is more problems in the 15th edition than the 20th edition, the 14th edition. Okay, so chapter 21. Chapter 21 introduces the concept of, let me share with you the screen in here. Oh, share. Okay. What was the main thing that we've learned from Physics 4a? What is the most important thing? You guys remember?
Would that be Newton's laws, like we were talking about earlier?
Okay. That is it. That's the main thing. That's what you should have, if anything at all. If anybody else asks you, hey, what did you learn from Physics 4a? It's really this law. Okay, let me get into my pen in here, my writing. It's F equals to ma. Come on. Why is this not? Oh man, it's not writing in the screen. It's taking me to the other screen. Let me switch screens since that's the case. Are you still looking at the same thing or not? Yes or no?
Yeah, it's just the NASA background.
Okay, so let me stop sharing then because it's not doing that. Come on. Sorry about this thing here. Okay, stop sharing screen in there. Share screen. Okay, you're supposed to be looking at the OneNote thing there, yes? It says chapter 21.
Yeah, I see it now.
Okay, very good, thank you. So basically what we have in here is F equals to ma. So that is really the main relationship that you guys have discovered in that class, yes? Because it boils down to the second law of Newton. The second law is the most important law that you have discovered in Physics 4a. Here is the deal now. People have observed that charges, which is really a phenomenon associated with lightning, associated with other things. And at that time, there were the shamans, there were all kinds of superstition and things like that was associated with it. And one of them is the idea of charges. So people experimented with it and they basically took different kinds of charges. So for example, if I know how much charge in here, and even if I don't know how much charge in here, I can take a similar shaped object and put it next to it, and there will be an exchange of charge. And they experimented with it. They put the two charges at this distance. They measure the force attached to a spring, mass spring system, and they saw how much the spring basically is compressing or elongating, and that measures of the force. Push them further away and see how the effect of the distance is going to be. Now, instead of having this much charge, reduce this one by another factor by bringing another mass and putting it next to it of a similar shape. Now I have basically taken this mass and divided by 2, and this I leave it the same. Now, how is that impacts the force, the force between them, basically how the spring is reading. So basically they found this law that Mr. Newton summarized it to being this expression, that this force between the two charges is proportional to the charges themselves and the inversely proportional to the distance squared. So now this is known as Coulomb's law. Actually, this law is not complete unless we put a vector in it, because the forces are vectors. So I have to include in here the r hat, and the r hat is a vector that is actually connecting the two charges. So if I label this one Q1, if I label this one Q2, and the distance between them is what I call R, okay? If, this is R, by the way, if I'm examining charge 2 will be subject to a force F on 2 due to charge 1, given by, where this is the R hat now, I'm going to label it 2 on 1, I'm sorry. So it's going to be, again, that constant, which has to do with a medium, basically. If you do this experiment somewhere else other than air, it's going to have a different constant in here. So that just a constant has to do with a medium times the product of the two charges, where Q1 and Q2, the other two charges, divided by the distance squared times the R hat. So this force could be here. So this is the force on 2 to 1. If I am interested in the force on 1, I mean the force on 1 coming from 2, it's the same, a similar scenario. This is the unit hat now on the vector that I'm labeling it on the position 2 or charge 2 coming from on charge 1 coming from 2, and this is the force on it. So this is the force F1 on 2. Before going any further in here, can I ask you a question? In magnitude, how is F12 is related to F21? Let's say, for example, this is 10 Newton. How much do you expect this one to be? I need to see the chat in here. Can't see it. When I'm in full view, I cannot see the chat. So if somebody's putting things in the chat, I cannot see them. What's the answer? If this one is 10 Newton, how much do you think the other? How much?
-10. Just
in magnitude. In magnitude.
Oh, no.
So if this is 10 Newton in magnitude, this is the magnitude of this one. I mean, the direction, you're right. I mean, if I'm going to take a position and direction, but the magnitude only without the sign thing.
Would it just be 10 then?
It's going to be 10 Newtons also. Yes, absolutely right. Okay. And the reason why you put the negative sign, can we invoke a reason why this must be the case? Why the two forces must be equal in magnitude but opposite in direction? Who said that? Which law enables me to say that? Andrea, you mentioned it earlier.
Would it be the second law?
It's going to be Newton's law of motion, yeah, because he's got 3 of them.
Mm-hmm.
The first law says that if an object is under no net forces, that object will retain its velocity. If it was stationary, it's going to stay stationary and moving forever and ever. The second law, if an object is under a net forces F, in this case, it's going to accelerate by the second law. The third law says that if an object, 1, exerts a force on 2, 2 exerts a force on 1 that is equal in magnitude and opposite in direction. And that is the, what number is that? Which law is this? Correct? Yes? This is the third law of Newton. So, you guys comfortable with these laws of motion and everything else? Correct? Yes or no?
Somewhat. Personally, I need to brush up on them a little bit.
They are crucial. Okay, they are actually important. Cannot do much. Okay, we cannot do much without them. Okay, we cannot do much without them. Just, I mean, you don't have to, can you tell me, you don't have to actually say it verbally, but can you tell me the instructors where you had this stuff in there? Because it's a big deal, okay? Did you have 4A with who? I know it's just fresh from the oven, especially being in online. How did you do 4A? Did you do it on campus or somewhere else? You guys need to engage, need to participate. Okay. Yeah, the laws of motion are very, very important, okay? We're not going to be really delving a lot in them, honestly, but you have an understanding of them. Here is the promise for the entire physics 4B, okay? Here is what 4B is. It's this thing. The entire course is dealing, with this expression, except we're trying to find F, that's all. We're in the hunt of F in this class. Because we're assuming that once we find F, we should be able to find the acceleration, okay? We should be able to go back and resolve this equation and find what the acceleration is. So that's really in a nutshell what this class is. So Mr. Coulomb, this is Coulomb's law, by the way. So Mr. Coulomb came up with this law between charges, that this is 1 over 4 pi epsilon naught times the product of the two charges divided by the distance squared. What he noted also is that the charges can have similar signs. This is not something, this is very, very similar, at least formally. It looks like the law of gravitation that you guys saw in physics 4A, which is minus g times m1 times m2 divided by the distance squared times r hat. That expression tells you about the gravitational force. And it's always negative because the masses are always positive. So it's an attractive force between different masses, the sun and the earth and a satellite, the earth and the moon and the astronaut. It's always negative because it's an attractive, it's an opposite direction. So if I have an object, come on, 1 and an object 2, this one has m1, that is m2. This force, gravity, is always towards the other one. So it's an attractive force. Whereas in this situation, it's not. If the charges are the same, this force is actually a repulsive force. A negative charge and a negative charge will repel one another. This sign is positive, actually, because Q1 and Q2 are positive. Q1 and Q2 are negative, their product is still positive. So in this case, the force is going to still repulsive. You guys understand that? Whereas if the signs are different, they are different kinds. Say, for example, I have a proton and an electron. Those are two different signs. One of them is positive, the other one is negative. A positive type of negative, it's going to be like this one, negative also. So it's going to be attractive. See the distinction between Coulomb's law, this is Coulomb's law, by the way. And this is Newton's law of universal gravitation. This is something that you also saw from physics 4A. So this is now the force of gravity, basically, the force of electricity now, how charges interact with one another. Does this make sense to you guys? Now I lost my note. Does it make sense to you guys, at least how the expression look like?
Yeah, it's pretty straightforward.
Yeah. Okay, so again, that is basically how this law is. So again, like I said, we are trying to find this force. At some point, we will find helper stuff to find it, namely the electric field. And at some time, we're going to introduce the magnetic field. But don't lose this in the background. This is going to be always, what is the purpose of the electric field? What is the purpose of the magnetic field? It's actually to find this thing, to find this force. Because once we find the force, we're back in business. We're back to going back F equals to ma. As a matter of fact, most of the work nowadays in physics is trying to find forces, interactions. Okay, that's all. Because we know the basic laws. At least that's how these things work. So we have an understanding of how these things work. Do you guys understand that? Okay, I have something to tell you, since we are still talking about business a little bit. And since this video is playing behind me, this coming Thursday, we will have a short class because I have to actually, okay, watch the messages, okay, because I'm supposed to host an event this Thursday with the STEM Center, and you're actually invited to it for the landing of the Mars rover. The Perseverance is going to land this Thursday. So, and I'm not too worried about your class, honestly, because you guys don't miss Monday and Wednesday. I have other 4 classes, basic classes of the calc-based classes that meet Monday, Wednesday. And because there is May 31st, which is a holiday, which is actually a Monday, and March 31st also, which is a no school day, that's actually a Wednesday. So they're missing 2 days. So I'm gonna, please watch the communications. We might have to adjust at least the lecture on Thursday. Okay, for this coming Thursday, because I just remember that because of the fact that I have an event coming along, and you are strongly encouraged to attend the live meeting, because again, it's a big deal. Okay, this is the first time that we're going to be able to probably make oxygen out of the atmosphere of Mars and prepare for manned missions to Mars. So this is a big deal. Okay, and this is the heaviest rover ever built that's going to land on Mars. It weighs about 1,000 kilograms, a ton, basically, metric ton. Anyway, so that's about Thursday, okay? So again, this is the force that we're talking about. So this is basically some of the stuff that is related to this one in here. Now you ask, and it's a very legitimate question, okay, great. I mean, I know using Coulomb's law how to deal with one charge, 1, and charge 2. So if I know the numbers between them and I know the distance between them, I know the distance. I know the force. I mean, in Newton, so I can go back and solve for F equals to ma, provided one of these two actually is nailed. So I'm going to assume that this one is actually fixed. Okay. So if I'm studying Q2, then there's no problem in this case. We can solve for Q2. We know the force coming from there. We can find F equals to ma and so on and so forth. Here is the trouble with this problem, okay? What if I have a Q3 actually here too? And I'm still interested in trying to find the force on 2. How am I going to deal with this situation? What do you guys think? This class is all about thinking, by the way. I really don't teach physics more than I teach actually thinking. What do you think will happen? Let's say Q3 was not there. So I have this force, don't you think so? So this is the force on 2 coming from 1, correct?
Yes.
If Q3 is not there, we just saw that, yes?
Yeah.
Okay, let's suppose Q1 is not there. And only Q3 is there. Of course, we're still focusing on Q2. So this is force on 2 coming from 3. So now both of them are there, Q1 and Q2. So what is the force on 2, do you think?
Is it
Is
both
it
the
going to be,
forces combined?
sorry, what did you say, Taurus?
I was gonna say, is it both the forces combined in a direction that's like somewhat in between both those two forces?
So you add them up. Is that what you're saying?
Yes.
You add them up vectorally. So you say, okay, go to the tip of the end of one of them and draw the other one. And
Yeah,
this is basically the parallel to it, F21, which I'm sure you did in physics 1 or physics 4A. So this is the force on 2, which is the net result of the two charges, of the two forces.
Yes. Yeah.
Okay, you guys are right, except that there is a flaw in this argument. This is actually what we do. I mean, this is exactly what we do. But there is a problem. The problem is with the assumption themselves, okay? Here is where the problem lies. When I came up with F21, I said assume that Q3 is not there, but the fact that Q3 is there, it should alter this value. So F21 is not correct in a sense. When I said ignore Q1 when I'm trying to find F23, the fact that Q1 is there actually changes this value. So this should not work, yet it does. We gave a name for it. We gave it the superposition principle because we have no clue why it should work, but it works. You guys understand that? So this is superposition principle. I mean, the flaw in the argument is that we're saying ignore one and just find the other one with the old way of two charges. But the fact that one is there will impact both charges actually. And that analysis should be flawed. Yet it works. If we do this in the lab tomorrow, we will find that the net, we attach spring but this one by itself as if this one doesn't count. Let's say, for example, we find 10 Newton and then we attach another spring to the other one when this one actually is not there completely, and we find whatever number you like, okay? And then we put the two charges now there and we attach spring to this one still. We're going to find it moving in this direction with the geometric sum of these two vectors. It works. But justification of it is kind of cannot really say. So that's why we didn't call it a law, we call it a principle, okay? In other words, just use it, okay? You guys understand? So the force, first of all, let me write it down now. So the force on a charge of the jth order is 1 over 4 pi epsilon naught. That's using vacuum, by the way. The sum over all i's, where I is different than j, by the way. Cannot be counting this on qi, qj, divided by the distance between the I and the j squared, times the unit vector pointing from the j to the I. We're calculating the ijth particle. So ji hat, okay? So this is by superposition. In the case I drew earlier, it's just 3 charges. In the case of when you have a bunch of charges, like for example, if I have a lattice, for example, for an ASEL or sodium chloride, where I know that this is an ionic structure where the ions have specific values of their charges. And if, let's say, for example, I want to find the effects on the single charge that is sitting in there somewhere in the corner of that lattice, or that so we can find the force, at least according to this expression. You guys see that? Just find all the charges, the other charges, including the sodium and sitting in all of the corners and the chloride sitting in somewhere in the middle there, and that's it. You can do this algebra. You guys understand in principle that this is doable? I know the details probably give me the distances and the angles and all of that nonsense stuff. Yes?
Right. So in the part above that we just did with the 3 charges, so you're saying that it can be any 3 charges, like Q1 could be positive or negative, and same with the other 2?
Yes, that's a very good point. Algebraic sum. This is algebra also. When I say algebraic, it means take the signs into account. Algebraic. This is not in absolute values. This could be positive and negative everywhere, okay? As a matter of fact, the force could end up 0. And that's exactly what's going on in the case of sodium, okay? The charges are, I mean, if we exclude thermal agitation, then they should average to 0 forces, okay? Otherwise, the charges start to move around one way or the other, okay? Yes? Because if A is not 0, then we have a disaster before us. Acceleration better be 0 in that situation. Okay, if the acceleration is not 0, then this object starts to move. You better have sigma f equal to 0 in here. Total force, net force is 0. Okay, but that's a good point. You have to always keep track of what is positive and what is negative and where is sitting and where. Correct? Okay, I have a problem in here. Before we introduce the electric field, and we get into very far from what we are. If you guys have the book, in the 15th edition, it's problem 9, not 90, 90 we'll do it later on. Problem 95. Okay, from chapter 21, problem 95. Let me get the 4th edition book to also, the 14th edition book, if you guys don't, or, hold on, okay, let me get it. Okay, so let me make sure I have the numbers. From now on, I will try to carry both books with me. We are looking at chapter 21. Because I don't want you guys to have chapter 21 toward the end. It's problem 95 still, okay? By the way, problem 96 and 95 are similar, okay? So it's the same problem, 95. So that's what I was talking about earlier, that these two things are not the same. So what I'm going to do in here, I'm going to do this problem in here for you guys. And that is problem 95 from the book, okay? Okay, you are responsible during your exam preparations for all the discussion problems like the ones that we are doing right now, meaning it could potentially be a problem for review for an exam. Do you guys understand that? Including also the homework problems. So everything we do in class and the review and the homework problems are also review problems for your exams. Does this make sense? Yes? I want to make sure that you guys understand this point. Correct?
Yes.
Okay, very good. So problem 95 from the book says 3 charges are placed as shown in the figure. Let me draw the figure. So you have a big triangle basically in here. They give you the sides for this is a right angle triangle. So this angle is a 90 degrees in here. Oops. For some reason, it's not drawing correctly. So this is a 90-degree angle. And this distance in here, sorry about the this pen in here. So they gave you this distances. This is a 5 centimeter distance. This is a 4 centimeter distance. And this is a 3 centimeter distance, okay? And they said this is Q1. And this is Q3. And this is the Q2. So that's the drawing, okay? The magnitude of Q1 is 2 microns. That means Q1 in magnitude is 2 microcoulombs, okay? And the sign, we don't know. So we have no idea if Q1 is positive or negative. It's a good idea. This is why I'm doing this problem with you guys, to do what we're doing. Okay, while you're reading the problem, try to take key points, try to understand what they're going. They don't tell you the absolute value of Q1 is equal to 2 microcoulomb. They tell you in magnitude. So I put it in absolute value. How you put it is up to you. When you're solving a problem, try to always have some sort of a schematic and taking notes of what is given to you, okay? So, so the sign and the value of the charge Q2 are not in. Q2 also don't know what it is. That's something they didn't tell you what it is. And Q3, what is, in Q3, they gave you Q3 in actual algebraic form as positive. So we know it's positive 4 microcoulombs, okay? So we know what Q3 is. So that's the only thing that we know everything about it. We know its magnitude and we know its value. It's 4 microcoulombs positive. Q1, we know its value. We don't know its sign. Is it positive or negative? Q2, we have no clue what it is, positive or negative, with just Q2, okay? And they say, and then they tell you the, and the net force F3, so they gave you an F3 in here. They drew it this way. That is the net force that is on Q3. They tell you that that charge, that force, is entirely in the x direction. So if I'm going to draw the axes, so this is the x-axis, and this is the y-axis. This force is in the x-axis. That means its y component is equal to 0. That's what that means. They didn't tell me Fy is equal to 0. I put it there. The reason why I put it there is because the statement says is entirely in the negative x direction. So that means Fx or F3, this is the components of 3 in the y direction. That means its component in the x direction must be a negative number, and it's not 0, okay? Because the way they drew it. And that's basically all the things I can decipher from what was given. Considering the different possibility of Q1, there are 4 possible force diagrams representing F1 and F2 that Q1 and Q2 exert and Q3. Sketch this force configurations. Okay, so there are several scenarios. Either Q1 is positive and Q2 actually is positive. Okay, we know Q3 is positive. Okay, there is another possibility. If Q1 is positive, Q2 actually could be negative. The other possibility, Q1 is negative and Q2 is positive, and the last one is Q1 is negative and Q2 is negative. So those are the 4 possibilities they want you to draw. So, and they start to sketch the forces F1 and F2 on Q3. So let me grab a different pen in here in color, red one, and I'm going to draw the first scenario. So this is first scenario. The first scenario, Q1 is positive and Q3 is positive. So F1 must be repulsive force. And F2 also is repulsive force, because Q2 is positive and Q3 is positive. I mean, Q1 is positive. Let's look at scenario number 2. Q1 is positive and Q2 is negative. I'm going to take Q1 is positive, so it's still the same F1, but Q2 is negative. Okay. Let's take the third scenario. Q1 is negative and Q2 is positive. Q1 is negative. Q1 is negative, so that means it's pointing in this direction. It's attractive, and in here it's repulsive. Okay, and the last scenario in here is both of them are negative. That means that F1 is pointing this way and F2 is pointing this way. So we drew them all 4 of them. So we answered the first question. Okay, sketch the 4 possible configurations. B, using the sketches from part A and the direction of S, deduce the sign of the charges Q1 and Q2. which one will give me a force pointing in the negative x direction? Which configuration is that going to work? Is it going to be 1, where the two of them are positive, or 2, when Q1 is positive? This is 2, by the way, and this is 3, or a 4. Which one do you think is going to give me the correct answer? Which one will give me a sum that points in the negative direction? Is it the red forces, the green forces, the blue forces, or the gray forces? Remember, F3 per superposition is supposed to be F1 plus F2. Which one should be?
The blue forces.
Do you guys agree with him?
I agree.
Camilo? Okay, Taurus agrees. It is clearly the one with the blue forces. Do you guys see that? And that is case number 1 or 2 or 3 or 4 from the diagram. It's this one. Are you going to say something?
I was going to guess.
Yeah, it's this one. It's actually Q1 is negative. It's attractive force. And Q2 is repulsive. It's pushing this way. The sum is this way. Do you guys see that? Do you guys understand why the 3 is the case? And the blue ones are?
I do.
Correct?
Yeah, I get it.
Okay, so Q1 is negative and Q2 is positive. That's the answer to part B, to the question. Okay, so we have answered something in here. We have answered, we know that Q1 is equal to 2 microcoulombs. Not only that, but we know that actually Q1 is equal to negative 2 microcoulombs. So Q1 is actually equal to negative 2 microcoulombs. So we have answered that. We still don't know what the value of Q2 is, but whatever it is, it's positive. Do you guys see that? It has to be. For the force to be pointing in this direction, it has to be positive. So that we answered question number B. Question number C. Calculate the magnitude of Q2. So we need to find Q2. What do we know about this problem? We know that the y component is equal to 0. Let me draw this one clearly, okay? Let me focus on Q3. Forget about the other charges for right now. Here is Q3, sitting beautiful by itself. It's subject to this force in here. This is coming from 2. It's subject to this force also in here, coming from 1. The point in here is when I add this them, it's going to give me this vector. That is F3. This is the sum of them. So let me call angles in here, okay? This is a 90-degree angle, by the way. That means this angle is 90 degrees. Okay? So if I'm going to call, from the geometry again, this angle alpha, this must be 90 degrees minus alpha. I know exactly what alpha is, by the way, since this is 5, and this is 4, and this is 3. I know the cosine of alpha. This is the hypotenuse in right angle triangle. It's 4 over 5. So cosine of alpha is 4 over 5. And its sine is 3 over 5. Remember, the geometry gave me a right angle triangle. And they told me this is 4 centimeters, this is 5 centimeters, this is 3 centimeters. So I know the trig of this angle. I don't know what its value exactly is. I can do the arc10 of 3 over 4 and find what that number is, but I don't care for that number. All I care is its cosine and sine. Because this angle is actually here too. This is alpha. And this is pi over 2 minus alpha. Because this is a 90-degree angle. So when I add them up, it's going to give me this one in here. So what I'm going to say in here is F1 times cosine of alpha plus F2 cosine of 90 degrees minus alpha is equal to, basically, I'm going to take the absolute value of F3, okay? Because I took everything in the negative direction. Technically, I should put negative sign everywhere and cancel the negative sign. So that's going to give me these values. I know what F1 is. It's 1 over 4 pi epsilon naught times the product of the two charges. And I know what F2 is. But I know also in the y direction, I have 0 force. In the y direction, they add up to 0 because the force, the net force is 0. So this one and that one, they cancel. So what I will have is F1 times sine of alpha plus F2 sine of alpha, or 90 degrees minus alpha. Basically, now I'm dealing with the opposite to this angle. I'm going to take it in negative sign because I have to take it in. One of them is pointing down, the other one is pointing up, okay? And the other one is this component. So this is the component, the opposite to this angle, which is 90 degrees minus alpha, and this is alpha itself. So this must be equal to 0 because they cancel. The entire force has no component in the y direction. So let's do stuff. I know what sine of alpha is. It's 3/5. Do I need sine of alpha 90 degrees minus alpha? There is a theorem that you guys did in trig that sine of the difference between A and B is equal to sine of A times cosine of B minus sine of B times cosine of A. And this is 0 because A is 90 degrees. Because this is 90 degrees minus alpha. So this is sine of 90 degrees, which is 1. And this is actually cosine of alpha. Cosine of B in this case is alpha. So this whole thing then is just cosine of alpha. And cosine of alpha from my geometry clearly is equal to 4 over 5. So this is 4 over 5. And this is 3 over 5. I didn't care to convert from centimeters to meters at this point because the ratio of the centimeters and the meter cancel. The cosines are ratio of length, so they don't matter. So now it's a matter of just finding these forces. So let's go into the second equation now and find it with the net forces. So we have 3/5 times F1, and F1 is the force between Q1 and Q2. F1. Now to go back to your question, Andrea, I already took care of the signs. I don't need to put two more signs, because if we put the signs now, that's going to be double jeopardy, because I'm assuming that this expression is already in magnitude of F1 and magnitude of F2. So you have to be very keen to this point, okay? Because we already have taken the diagram into account. So when I'm solving now, I'm going to take the absolute values. So absolute value of Q1 times the absolute value of Q3 divided by the distance squared, and the distance squared is the 4 centimeters squared, but don't forget to convert it into meters. Minus the sine of 90 degrees minus alpha, which is cosine of alpha, which is 4 over 5 again, times again the product of the two charges, Q2, in magnitude. We know it's sine already. We solved that issue already. Times Q3 divided by, I'm sorry, I forgot the 4 pi epsilon naught. 4 pi epsilon naught in here, times the distance squared, and the distance squared is 3 times 10 to the negative 2 squared equals to 0, okay? Q3 cancels from both sides of the equation because it's everywhere. And also the 4 pi epsilon naught cancels because it's everywhere. The 5 also cancels because it's everywhere. And the 10 to the negative 2 and the 10 to the, that's why I could have left it in centimeters and nothing would have, no harm could have come. So this number cancels and this number cancels. So what I'm left with is the following. 3 over 16 times Q1 in magnitude minus 4 over 9 times Q2 in magnitude equals to 0. From here, I can find the value of Q2 in magnitude equals to what? 9 times 3, that's 27, divided by 4 times 16, which is 64. So it's going to be 27 over 64 Q1. And I know Q1 is 2 microcoulombs. 2 cancels the 64, and I'm going to end up with 27 over 32 microcoulombs, okay? But it is positive. I know it's positive before the previous argument. So we know its magnitude and we know its value. So what we used in here, we used the condition that this force has no y component. And in this expression, Q3 cancels because it's common for both of them. And I do a lot of algebra in here to go back into the same point so that I can emphasize on it again. And I know Andrea mentioned it earlier, and I made a big fuss over the fact that this is an algebraic sum. In here, I already took care of the signs when I drew this force diagram for Q3, okay? So there is no need now. If I put it now, I'm going to be in trouble, okay? So there is no need now to put it again. So I'm dealing with the absolute values because the force is already fully accounted for with the drawing that we did. The last question is to find F3 in magnitude. F3 in magnitude should be just basically equal to, again, F1 in magnitude. So this is just the magnitude of F1 times the cosine of alpha plus F1 in magnitude times the cosine, F2 times the cosine of 90 degrees minus alpha. If I do the same trig identity, I have cos of 90 degrees is equal to 0. Do you guys remember your trig identities? Cos of A plus B is equal to cos of A, cos of B, and in exam time, I'll give you these formulas in here, equal to sine of A, sine of B, and this is equal to 0 because A is 90 degrees again. So this is 90 degrees, so this whole thing is gone, and sine of 90 degrees is equal to 1, because this is 90 degrees, and this is minus alpha, because in the expression I have a minus in there. So the minus cancels the minus, and this is going to be just the sine of alpha. So cosine of 90 degrees minus alpha is the same thing as sine of alpha. So having said that, I'm going to plug in the values now. So F3 is equal to 1 over 4 pi epsilon naught. That's common for all of them. Times Q3, that's common for all of them. Times what I'm left with is Q1 now in magnitude. Make sure it's in magnitude, divided by the distance squared. Now I cannot not convert. I have to convert, otherwise I get some nonsense. So this is the 4 times 10 to the negative 2 squared times cosine of alpha. Cosine of alpha, is, if you guys remember, is equal to, from this trig simple geometry, 4 over 5. 4 over 5 plus Q2, again in magnitude, divided by the distance squared, which is 3 centimeter, 10 to the negative 2 times 3 over 5, and the whole thing gives me the force now. Do you guys understand how this works for this problem? I'm going to leave it to you guys to finish the numbers. 1 over 4 pi epsilon naught, by the way, 1 over 4 pi epsilon naught is equal to 9 times 10 to the power 9 SI, which is Newton, divided by Coulomb squared, and times the distance squared, okay? So that's the units for the 1 over 4 pi epsilon, which is a constant. And you have the Q1 and the Q2, and the micro is 10 to the negative 6, because there is a microcoulombs in here, there is a microcoulomb in here, and there is a microcoulomb in here, okay? So it's going to be 10 to the negative 12, but don't forget you have 10 to the positive 9, and that should be, this is 1 over 4 pi epsilon naught, not 4 pi epsilon naught. 4 pi epsilon naught is the invert of this number, okay? So, and don't forget 10 to the negative 2 squared, that's 10 to the negative 4. You do the algebra and you're going to find the value in force in here in Newton. I hope you guys can finish this problem, at least the algebra. Do you guys have any question about this problem?
There's one point where you simplified a fraction. I kind of got confused on it. It was when the writing was blue.
Hold on, let me share with you this point.
Yeah, when you went from 27 over 64, it's a little bit lower, but 27 over 64 to 27 over 32. How did you get that?
Q1 is equal to 2 microcoulombs in magnitude. The 2 is coming from Q1. Remember, Q1 is Q1 itself is negative 2 microcoulombs.
Oh, okay.
I sub the value, that's all.
Got you. Okay.
Okay. So it's going to be 27 over 32 microcoulombs. And it's going to be positive because we know that from solving this case. Okay. From here, we know it's positive. So whatever number we end up with, it's going to better be positive. So it was 27 over 32 microcoulombs in absolute value, but now we know it's sine 2. So we know it's sine actually from previous stuff. For F3, it's just the force times the cosine of this angle plus the force times the cosine of the other angle, but everything is in the negative direction. So I have to take the magnitude of this vector times cosine of alpha, the magnitude of this vector times cosine of this angle, which is, because this is a 90-degree angle, so this must be also 90 degrees. So this one is just the complement to this angle, alpha, so which is 90 degrees minus alpha. I could have called this one beta if you like, okay? And I know what cosine of beta is going to be. And I know this angle is equal to that angle too, because you have two parallels and you have the same line that cuts them from way back when you were doing geometry, that this angle and that angle are the same, okay? So now, you know what cosine of this angle is too. The cosine is the adjacent, which is 3 over 5, and the sine of this angle is just the opposite, which is 4 over 5. Same thing. I could have made that argument and used in here the fact that I'm dealing with the cosine of alpha and the cosine of beta, and I would have gotten the same answer because the cosine of complement angles is the sine of its complement, and the sine of the complement angle is the cosine of its complement, and so on and so forth. This is from way back in trig, but I really want you guys to be one of the things that you're going to discover also is that you cannot do physics without trig. So you really have to know those trig identities. So they will be very, very handy. Come in here, okay? So this is because it's a right angle triangle, they give us almost everything in this problem. So from the fact that this cancel, there is no y component, I can find what Q2 is. And I can find it not just I already resolved the sign from the direction of the force. Now I'm going to find its numerical value, and the numerical value, append to it the sign, and we're in business. Now it's a matter of just calculating these two forces using the superposition principle. All of this is resolving on the superposition principle. Without the superposition principle, we will never be able to do this class at all. So from now on, the superposition principle is your FBD. What is it? Your no. What is the your FF. I'm sorry. Okay. You know what that is? Your BFF, that's what I meant to say. You see, I took COVID vaccine, my second one yesterday, so my brain is not really functioning 100% right now. So this is your BFF for this class. You guys know what that means?
We're going to be using
Yes.
it for everything.
For almost everything, okay? Whenever in doubt, invoke your best friend forever, okay? He's gonna come to the rescue. Believe it or not, it's true for almost everything that we're gonna be doing in here. Again, we don't really have a justification for it, but it works, okay? So again, we use the superposition principle to justify the fact that F3 in this case is the sum of the two forces. And the fact that this force has no y component gave me an algebraic expression to find what that force is. The nice thing about that one is that Q3 cancels actually from both sides. Q3 and Q3 is gone. Okay, This 5 is the denominator. Basically, all that matters really in this case is the tangent of that angle, okay, alpha, because the hypotenuse of this triangle doesn't matter really then. And then the conversion really is not needed, which is really something. Sometimes don't try to immediately convert to the meter because they gave you things in centimeters. Keep it as is, okay? One word, I know they still have 5 minutes before the class is over. One word about the units, okay? We use the Coulomb for the charge. When you guys did physics for A, they made a big fuss over the fact that the MKSA system, MKSA, is meters for distance, kilogram for mass, and second for time, and A for ampere for the current, okay? We just introduced the Coulomb. Coulomb is a force that is a charge, is a unit that measures charges. Unit of charge. This is not a fundamental unit. It must resolve to the combination of these parameters, and it does, okay? It's going to be related to the ampere and the second. So for right now, we use a Coulomb, which is like the Newton. Newton is not a fundamental unit, if you guys remember from your discussion. Newton is a force, is a mass times acceleration. So it resolves to the combination of the other three. Kilogram times mass divided by the second squared. And so is a Coulomb, by the way. It's not a fundamental unit, but it's a useful unit that we use. Now, you cannot go and find a 1 Coulomb laying around. It's too much of a charge. So that's why in real life, you will be dealing with a micro Coulomb, with I don't think millicoulomb will be also appropriate. A nano Coulomb, even a pico Coulomb. So this one is 10 to the negative 6, this one is 10 to the negative 9, and this one is 10 to the negative 12. Okay, so that's really the in terms of practicality of it. So 1 Coulomb is too much of a charge. If I put 1 Coulomb and another 1 Coulomb, this is going to blow up very quickly. I mean, okay. On Thursday, again, I'm not decided yet on it. If we're going to meet, we're going to finish this discussion, namely on the electric field. And if not, then we're going to finish this discussion on Tuesday of next week. Okay. Any questions for me? Still have about 2 more minutes. So don't forget the discussion item today. I made it just simple today. Otherwise, I would have required that you guys complete the calculation, which you are required to do anyway, but you don't need to post it in on campus. Or problem 95. If you like, you can do also problem 96. It's 96. It's identical. The exception is you play a little bit with the direction and stuff like that. Okay. Questions? If you don't, guys, have any questions, so I'm going to post this video later on. Hopefully, you guys will, the ones who are not in class, they will follow also the same stuff. No? Okay. You can always message me about any question, okay? If you want it private, that's fine. But if you want the discussion also to benefit everybody, that's fine too. Okay. But just to answer a Taylor question quickly, I mean, you really don't, like I said, we don't really need a lot of things from the back. All I want you to do is focus on this stuff in here, okay? And please do ask. If I say something is important, that means it's very, very important. It may impact your exam. So please do ask about it to understand it. Okay. We can start another session, okay? Bye, everybody.
Thanks, Professor. Goodbye.
Bye.
Have a good day.
Bye,
See you
Professor.
later.
Bye. Okay, everybody can leave except Tyler has got a question for me, okay? Shirsha. Okay. Tyler, can you turn on? Okay, let me stop the recording first.